Hello friends, welcome to my YouTube channel Aviator Updates. If you don't know me, I am Rakesh Negi and I am an aviation enthusiast. In today's session, I'm going to discuss about the basic high energy ignition system of turbine engines. So let's start. High energy ignition system of turbine engines. Okay friends, so let's start the topic high energy ignition system. So you must be knowing friends that the high energy ignition system of turbine engines is much more simple as compared to the piston engines. Why? It's because the number of components which are used in this system are less, and also that the electrical ignition of the air fuel mixture is required only during the starting phase of the engine, right? And also that the electrical energy which is produced by these high energy ignition systems are very much higher as compared to the piston engines. Why? This is to ensure the ignition of the atomized fuel in the combustion chamber and also to meet the problems of relighting an engine in air. Okay, so now let's discuss the components of the basic high energy ignition system. These are the high energy ignition unit and the igniter plug. Both of these components are interconnected and these are present 2 in numbers in an engine. And also friends, I would like to tell one very important point about the mounting of the igniter plugs. The igniter plugs are located diametrically opposed in the engine so as to ensure a positive and balanced lighting during engine starting. So now let's discuss the schematics of the basic high energy ignition system in the turbine engine. As in this session I am explaining the basic high energy ignition system, I am considering the DC supply as the input. In my other session I'll be explaining about the AC high energy ignition system for the turbine engines. Okay friends, so now let's go ahead. Suppose this is the bus bar. Okay, this is a 28 volt DC bus bar. Okay, we know well friends, in aircraft we use 28 volt DC as the standard voltage, right? Suppose this is the bus bar which is carrying the 28 volt supply. Now from this 28 volt DC bus bar, we know well we can give the supply to a number of components. In this system I am just discussing about the high energy ignition system. So the high energy ignition unit is the one which is going to use this as the input. Okay, let's go ahead. Suppose this is the supply which I am taking from this DC bus bar. This is a circuit breaker, suppose like this. Okay, it is closed. From here the supply is going ahead like this and waiting at this point. Okay, so the current is flowing from the DC bus bar and waiting at this point. The other point is this one, which is of a contactor. Okay, I am drawing a contactor over here. Now this contactor will close in case its coil gets the supply. Suppose this is the coil which, if energized, will pull this contactor down and have the circuit closed. Okay, so this coil is going to get supply from the same bus bar. So I am taking another point as like this I have taken. So I am taking this point, going down like this, and I am giving this supply to this by means of a switch which will be there in the cockpit. Suppose the name of this switch is start switch. Start switch. Okay, so this switch is in the cockpit. When I turn on this switch, it will close this circuit and it will close this circuit like this, and this is connected to this loop. It will cause the current to flow in this. I'll explain it after some time. Also in this DC bus bar, one more point is connected, and that point is connected to a relight circuit. Okay, suppose this is the relight switch which is open as of now as like the start switch. So this is the relight switch. Okay, so this relight switch is connected to this point. Okay, So when is the relight required? Suppose you are in air and in flight, relight is required. So when I select this switch to the closed position, current will flow from here and go in this loop, and it will energize this coil, causing this contact to close. And what will be the effect? It will operate a unit called as the high energy ignition unit, which I am going to explain shortly. Okay, so whatever supply comes from here goes by means of this switch. Suppose I am connecting a diode here, rectifier here. So this is converted to pure DC and then it goes to the coil. Okay. So friends, as of now, what I have explained is the supply from the DC bus bar, which is the main bus bar, okay, is connected by means of circuit breaker, okay, like this, and the supply is going and waiting at this point, right? Next, we have discussed that the DC bus bar is also providing supply by means of circuit breaker like this. This is a closed circuit breaker to this switch, and the supply is waiting at this point. Also, the DC bus bar is providing supply by means of a circuit breaker like this, which is a closed circuit breaker. The supply is going and waiting at this point. Okay, let's go ahead. So the supply is waiting at this point. If this contact is closed, okay, then supply will go ahead like this and is given to a coil called as the induction coil. Okay, and this induction coil is connected to a trembler contact mechanism where we have contacts like this, and those contacts are connected like this by means of a capacitor like this. Okay, these two are the contact points. This is a capacitor and it gets the grounding path like this. As I'll explain this further, you will get to know about this trembler contact. It is trembler contact. Okay, I'll explain this in more detail as we go ahead. So this coil is basically a part of the unit called as the high energy ignition unit. Okay, so I'm drawing a dotted line like this to enclose the components of high energy ignition unit. So what all other things are there in the high energy ignition unit? Let's learn. So this is the core which I am drawing here, and this is the other coil. You can consider this unit as a transformer. Okay friends, a high voltage transformer. So what happens here is, suppose the supply is flowing, okay, this start switch is closed. So when this start switch is closed, current will flow from here by means of this diode. It will be rectified and that particular DC current, pure DC, will be given to this coil. Okay, when pure DC is given to this coil gets energized and produces a magnetic field. That magnetic field, it attracts this contact here, and this switch is closed. When this switch is closed, okay, the current which was flowing and waiting at this point will move ahead like this, and that DC current will flow in this induction coil, okay, causing a magnetic field to be produced in this. And since it is a DC current, the magnetic field is stationary, right? Now, how will this magnetic field be moving then? And why I'm talking about moving magnetic field over here? It's because since I'm considering this as a transformer, okay, high voltage transformer, we know that friends, EMF will be induced in this coil or the secondary coil of this transformer only when the magnetic field will be moving. Okay, that means when the magnetic field will move and cut this conductor, right? Then in this conductor or coil, which I am considering as secondary, an EMF will be induced. Okay, so I repeat again, in this secondary coil, EMF will be induced only when magnetic field will cut it, and that magnetic field will be of primary. Okay, so the primary magnetic field need to be in the moving state. For having the magnetic field of the primary in the moving state, what I do is I have connected a trembler contact mechanism. This trembler contact mechanism, how does it operates? Let's discuss. Since here it is open, it cannot follow this path to have the grounding. Okay, that means the current which will be coming from here, it will follow this path, and since here capacitor is there, it will be storing the charge first. Okay, and when this is sufficiently charged, it will discharge. Okay, it will discharge and it will close this contact, and when these contacts are closed, the current will get the grounding path from here. Okay, so this continuously charges and discharges. Okay, so this capacitor repeatedly charges and discharges, causing these contacts to open and close, hence the name trembler. Okay, this cycle of recharging and discharging of this capacitor keeps on repeating as the circuit is in operation. So when this thing is happening, we should note that these contacts are also opening, closing continuously. And when such thing is happening, the current which is flowing in this coil will also get grounding path and have its grounding path disconnected. That means the current will be fluctuating. Because of this current fluctuating, magnetic field also will be fluctuating, and when this magnetic field is fluctuating, we can say it's moving, and that moving magnetic field cuts the conductor of this secondary coil, and hence an EMF will be induced in the secondary coil. Okay, and that will be a very high tension voltage. Okay, and it is of AC nature. Now this AC, I want it to be in the DC state. Okay, so in DC state, how it will be? I have to connect a high voltage rectifier. Suppose this is a high voltage rectifier which is connected in the circuit. Okay, so the output of this rectifier will be now DC, right? So this DC is given to a capacitor which is called as reservoir capacitor, or you can say condenser. Okay, so this capacitor used to charge now, and how is it getting charged? It is because of this DC. Okay, so it will charge, and both of these are connected together like this to a grounding path. Okay, like this. Hence their circuit is completed because they are getting the grounding path from here, right? So friends, from here, note that this capacitor or reservoir capacitor or condenser will charge until its voltage is sufficient to break down a sealed discharge gap, usually around 2000 volts. So when it discharges, it flows from here in this circuit by means of a unit called as the discharge gap. Okay, now what is this discharge gap? Discharge gap. Okay, and what was this? Reservoir capacitor. I'll write here. Reservoir capacitor. Okay, so this is the reservoir capacitor. So what is this discharge gap? Let me explain, friends. Discharge gap is made of two tungsten electrodes. So if you see these two, these are the tungsten electrodes, and they are inside a sealed chamber, okay, within which there is no air, okay, but there is inert gas. Okay, so these two tungsten electrodes are kept inside a sealed chamber containing an inert gas which is exhaustive of air. Okay, so this is called as the discharge gap. So in this discharge gap, what happens? While the capacitor is discharging, it will follow this path, and there will be a arc discharge like this from here to here, from this electrode to this electrode. Then it will go ahead, and by means of a choke like this, CHOKE, choke. So this is the choke. The high voltage goes ahead, and by means of this high tension leads, it is given to the igniter plug. Suppose this is the igniter plug. Okay, so this is igniter plug. Okay, so this igniter plug will produce spark. Okay, so if this igniter plug produces spark, you know, well friends, what will happen? The air fuel mixture will be ignited. Okay, so let me come back here. Why is this choke required? This choke used to extend the duration of the spark the igniter plug will be producing. Okay, so friends, from here we came to know how the igniter plug used to produce the spark across its phase. Okay, the high voltage comes from the reservoir capacitor when it's discharging. Okay, so when it is discharging, the discharge passes through the discharge gap, sealed discharge gap, and when it goes through this, it passes by means of a choke which used to extend the duration of the spark, and by means of the high tension ignition leads, the high voltage is given to the igniter plug, which is placed in the combustion chamber, and hence the air fuel mixture is ignited. Once the air fuel mixture is ignited, friends, we know that, friends, the flame from one flame tube goes to the other flame tube by means of the balance pipe, and that's how the combustion chamber becomes self-sustained with the flame, and hence the ignition system should be switched off. And when we switch off, friends, there is no spark in the igniter plug. But remember that, friends, after switching off, the reservoir capacitor may have potentially lethal high voltage, and this high voltage is grounded by means of resistors called as the safety resistors, which I have not shown you earlier. So these are the safety resistors. Okay, what are these called? Safety resistors. Okay, so friends, I hope you got the purpose of these safety resistors. The purpose of this safety resistor is to provide grounding path to the residual voltage which is stored in the capacitor when the ignition system has been turned off. So it used to discharge by means of this path, and hence there is no residual voltage or potentially lethal voltage in the reservoir capacitor when the system is switched off. So thanks to the safety resistors. So friends, I'll just complete this dotted line now, as I have drawn the complete diagram. So this dotted line is enclosing the high energy ignition unit, H.E.I.U. Okay, and also in the system, as a part of the safety, in the output of this choke we can keep a voltage limiter and provide grounding path like this. Okay, so this is the voltage limiter. So friends, this is the circuit of high energy ignition unit. And also friends, some manufacturers, what they do is they can even introduce an annunciator light like this. Okay, so what is this? So this is an annunciator, and they can give the name as ignition on light. Okay, so whenever the ignition is on, when this switch is closed, when the ignition is on, they can get an indication or annunciation in the cockpit that the ignition system has been switched on. Okay friends, so friends, I'll quickly summarize what we have discussed today. We have discussed about the basic high energy ignition system in turbine engines, where we have discussed that the high energy ignition system in turbine engines is much more simpler as compared to that in the piston engines, right? This is because less number of components are used in the turbine engines high energy ignition system, right? And also that the electrical energy which is required to ignite the air fuel mixture is required only during the starting phase of the engine, and also to cater for the problems of relighting an engine in air. Okay, so what you have seen here is we have given a low voltage to the high energy ignition unit, and it produced a high tension voltage which was given to the igniter for releasing the energy, or I can say for providing the spark in the combustion chamber. And also friends, we have discussed that this combo of high energy ignition unit and igniter plug is present 2 in numbers in an engine, right? And after that we have discussed about the operation of the high energy ignition system by means of this schematic. How does it operate? Let's discuss. Suppose this is the main bus bar, okay, which is powered by 28 volt DC. So I have used the DC system for explanation. I'll explain about the AC system in my other session. Okay, so from the main bus bars, these are the CBs which are closed. When these CBs are closed, the DC supply is going, and in this line it is waiting at this point, and in this line it is waiting at this point, and in this line it is waiting at this point. When this switch is closed, what happens is DC supply will go ahead like this. This rectifier will convert the supply into pure DC, and it will be given to this coil. This coil gets energized because it gets the grounding path. So this will magnetize the coil, and when it gets magnetized, it will pull this contact down and it will close this contact. So the current which was waiting at this point will go ahead and pass through this coil called as the induction coil. So when the current is passing through this induction coil, it charges this capacitor, and when this capacitor discharges, it will cause this contacts to close by means of an arc. So when this closes, the current which is flowing through this coil gets the grounding path and it gets magnetized, and soon after this again the capacitor discharges, it need to be recharged again. So in this we have discussed that capacitor will repeatedly charge and discharge and have these cycles of charging and discharging repeatedly, because of which there will be fluctuating current in this coil or induction coil, and that current will produce a fluctuating magnetic field or moving magnetic field. That moving magnetic field will cut these stationary secondary conductors and cause an EMF to be induced in it, a very high voltage EMF, and that high voltage will be obviously AC. To convert this into DC, we have a high voltage rectifier. The high voltage rectifier converts the AC, high voltage AC, into DC. That DC is then given to the reservoir capacitor for charging. So this capacitor charges until its voltage is sufficient to break down the seal discharge gap. So when it breaks down the seal discharge gap, this current or the high voltage goes ahead by means of this choke coil, and is by means of the high tension lead is given to the igniter plug, and igniter plug produces the spark. And note that friends, the capacitor usually is of 2000 volt. I mean to say, when the capacitor charging goes to a level of 2000 volt, then only it discharges. And what is the purpose of this choke coil? Choke coil used to extend the duration of the discharge which is through the igniter plug, right? And what is the purpose of safety resistor? The purpose of safety resistor comes into play when the system has been switched off, right? So when the system is switched off, whatever the residual voltage or potentially lethal voltage is there in the reservoir capacitor, it will discharge by means of this safety resistor, and that's what we want. Okay, and what happens when igniter plug fires? Whenever this fires in the combustion chamber, the flame will be there in the flame tube, and by means of the balance pipe which connects the flame tubes, the flame will spread quickly and continuously, and soon the combustion chamber will be self-sustained with the flame, and after that we can switch off the ignition system, right? Because we require the ignition only during the starting phase of the engine. After that, we have discussed that we can even install an annunciator to know whether the ignition system has been selected on or not. So we can connect it this way and provide the grounding part. So whenever this start switch is selected, supply will go to this ignition on light also, so that it lights, and we get to know in the cockpit that the ignition switch has been selected on. Okay, and what about this voltage limiter? As a measure of protection, we can connect it in this circuit like this. And what is this? This is the high tension ignition lead which is connecting the high voltage output of the H.E.I.U to the igniter plug, right friends? So friends, I hope you have enjoyed learning this topic. If there are any doubts regarding this topic, please do comment below. I'll come up again with a new topic in my next session. Till then, enjoy learning this topic, and thank you.